Okay, the law of sines gives us ways to do calculations on oblique triangles. An oblique triangle is one that does not have a 90-degree angle. So let's see what it is. Let's draw some triangle that is not a right triangle necessarily. And let's label the sides lowercase a, b, and c. And then the convention then that we'll use is to label the opposite angles the same letter. So if this is side A, the angle that's opposite will be angle A, but I'll write that with a capital A for an angle. Opposite side B will be angle capital B. Opposite side C will be angle capital C. Okay, so that's the convention that we'll use here for our triangles. Oops. So the law of sines says if your triangle is set up this way, then this is true. The sine of an angle divided by its opposite side equals the sine of another angle divided by its opposite side equals the sine of the other angle divided by its opposite side. So the key here is that you're taking the sine of the angle, that's why it's called law of sines, and you have to relate the angle to its opposite side. You can't have angle A and side B related. Okay? So you could use this version, or another version is to take the reciprocals of these three and have the sides on top. It doesn't matter, you can remember just one if you'd like. I tend to remember this because this one is useful. These versions are useful for solving for sides, right? Since they're already in the numerator. The top versions are useful for solving for angles because the angles are in the numerators. It's easier to solve for things that are in the numerator than things in the denominator. Alright. Now let's talk about what you need to have in order to use the law of sines. So let's focus on, you never use all three of them at once, you just relate two of them. So this is an example. There are four unknowns here, angle A, angle B, side A, and side B. If you want to solve for one of those, you need at least three of the four unknowns. So if you need at least three of the four, then you have to know a complete pair, right? There's no way to get by without a complete pair, meaning I have to know both of the B's or both of the A's. So the first thing that you have to be able to use for law of sines is we need an angle and its opposite side, right? That's what a pair is. If you have both B's, then you know angle B and side B, and they're opposite each other. So we need an angle and its opposite side. And then, if we know a pair, like both B's, then we need one other piece of information. So we need those two pieces of information. We need one other angle or side, right? So we need three pieces of information, a matching pair, an angle and its opposite side, and then some other angle or side in order to use it. Now I just want to mention the law of sines also works with a right triangle. So don't think you have to have an oblique triangle to use these formulas.